All right, let's give it a minute or so. But welcome to the fika. I hope you guys have filled up your coffee cups. At least I have a bulle. Let's see. Yeah, I think we should go ahead. So my name's Ebba Josefsson Lindqvist. I'm project manager for the Data Factory at AI Sweden. And we have some of my teammates here as well. So both Shetal and Eric, if you want to say hi real quick.
Hi everyone, glad to be here. My name is Shetal Reddy. I work as a data scientist at AI Sweden.
Great, thanks. And I think Eric just left us in time for his presentation, so maybe he'll come back later. He's a systems engineer and just started about a month ago or so with AI Sweden. So probably a few of you have met him already. And there's actually some more people dropping in, so that's really good. Super fun. And so we just started this initiative because we want, to create a space where data scientists and others can meet and talk about what you do in the data factory and the interesting projects you're working on. So we started this fika space. It's supposed to be really relaxed, and we'll have someone present each time. And then I think we'll have a few minutes over for questions and maybe start an interesting discussion. Eric, I introduced you as our assistant.
Great. Hi, everyone.
Perfect. So this first time that we do the fika, we have invited Johan Gustafsson from Recorded Future. So please go ahead, say a few words about yourself, and I will let some more people in. And I actually should just say that I'm recording the meeting, and we'll probably only, we'll share it afterwards, and only the presentations part, I think. But just so you know, everyone, that we're recording it. So
Gotcha.
sorry, Johan, please go ahead.
No, it's fine. I'll introduce myself with slides though. Let's see. Does this look right to you guys?
Yep, looks good.
Perfect. Hi, everyone. Thank you all for joining me here today. And thank you to AI Sweden for inviting me. I really look forward to hearing from the future speakers. My name is Johan Gustafsson, and I'm currently doing my master's thesis with Recorded Future on Logotype Detection. And that's what this talk will be about. So this is my plan for today. I will start by giving you an overview of what I've been up to in the past. And I will tell you a little bit about Recorded Future and how my work fits into what they do. I will give you a brief introduction to the art of object detection and then connect that to logotype detection specifically. I will wrap up the talk with some quick discussion of the tools that I use in the data factory. You're of course all free to ask questions throughout the talk, but I guess it's probably ideal to save them for last if possible. I can always jump back a few slides if needed. Yeah, so I grew up not far from Gothenburg. A huge part of my family has been in this area for many generations back. And my science teacher would always say he would give us cliffhangers at the end of the lessons, and he would then tell us that to find out the answers, we need to go to Chalmers. So essentially, I was brainwashed into going to Chalmers, where I've studied a mix of statistics and programming. I'm still very early on in my career, so these are a few summer jobs and internships that I've been fortunate enough to have. I figured it would only be appropriate to express them in logos instead of as a list. Yeah, so one of these stands out for a good reason. All of these companies are Swedish, except one. So they deserve a special mention. I worked at this company last year for my gap year. They are also in the cybersecurity space, but for email. It's really exciting to be back in that space. And if you want to learn more about it, then I really recommend checking out their reports. They write really accessible, like comprehensive reports on the way crime is done through email today. It turns out that a lot of the crime is still done by Nigerians, although they have learned since the days of the print scam. I also want to make a general recommendation that being in a space where you fight bad guys is really, really meaningful. It's a great way to derive meaning from. There's me. So Recorded Future, they collect a lot of data and model this and turn it into useful information that can be used by analysts and like different companies and nations and so on, governments. Historically, this has been done textually. There's a lot of great NLP talent in this company. I'm sure you've seen the talks at Gaia and so on. But so there's a lot of interesting information in the computer vision space as well. And making that accessible can make the world a difference. A lot of this information is being used, but it's curated manually, and like it's very clunky as of now. So this is something that we are looking into doing more of, and that's where I come in. So I will give a few motivating examples first. These are not at all related to Recorded Future, but I figure they will give a general sense of like why images are useful in intelligence and cybersecurity. In this case, we had a social media campaign in 2016 where ISIS supporter located in Europe would post these pictures in solidarity with the cause, just spreading terror, but also coincidentally giving away their locations. So this guy is the head of something called Bellingcat, which deals with open source intelligence. And they have a lot of geospatial talent. So they used these images to find these people. And in a lot of cases, the images led to their homes, which was then provided to authorities. So there were a bunch of these where like they would be exactly pinpointed to where they were found. Another case is this recent article from the New York Times. In this case, it was an article about how ships from China secretly send oil to North Korea, which they are not allowed to do due to international sanctions. And this work is really all due to satellite images and like this type of investigations where you compare the layout of ships and matching sizes and artifacts like that. A third case and more obvious to what I'm doing is this example of a phishing site. In this case, this was like highly individualized to people working in the Nepalese army. As you see, this is something resembling Outlook, the web access page for Outlook, with the Nepalese army logo to the left here. And using this type of attack, they would send them malicious documents and of course mine their credentials. So that leads us into object detection. So how do we go about detecting these logos, like the one from the Nepalese army in the first place? A lot of people might know about the ImageNet challenge in 2012, which is really where image classification using neural networks became mainstream. I think it's less commonly known that there was also two other parts to this competition. Fine-grained classification, where we, instead of classifying dogs, we have different breeds of dogs, for example. And there's also the localization challenge. So that means we want to find, given a class where in the image is that class. So if we know that there's a cat in the image, like where is the cat? This might seem trivial, like finding out that there is a cat in the first place seems like the hard part, but it's far from obvious. So back then, you would just slide the classifier all over the image, and you would have the box, the classifier would be the box, and the resulting score would tell you something. And then you would either remove boxes that are highly overlapping, or that have, or simply merge them into some final box. Then there's of course the more difficult problem of detection, where you have multiple items, since this just works for, I mean, it works for many classes too, but in this competition, there was only one object. Yeah, so the following year, this paper came out. This team won the localization and detection challenges by doing something new. So instead of just predicting classification scores, they would output box coordinates as well. This might make more intuitive sense, as like humans are typically standing up and tall, whereas something like a crocodile would be something that's very long but very short. However, we are still sliding the classifier along the image. So we're outputting more numbers, but we're still sliding along. And that's a lot of duplicate work. If we slide a classifier one step, then typically that doesn't add much. So if we can do less work that way, this will give us a lot of time saved. So there's typically two ways you reduce that workload. Either you just really make the number of possible proposed regions very small and output them directly at once. This is so-called one-stage detectors. This is YOLO, if you've heard of that. They are typically used for embedded systems, or like systems where speed is of importance. And combining that with a very light neural network makes it very accessible for phones and such. And then there's the other way, which is using two-stage detectors. There we do a lot of proposals, but still very much fewer proposals than the other case. And it's much more accurate. And it's something that we have looked at because it's more important to us to find the right things than to find them in milliseconds. So the first type of successful region-based proposal uses a segmentation-based method. So you turn this image into a very highly segmented image, and then you merge the different segments into bigger and bigger pixels. And using these segments, you create boxes. It might seem like a bunch of work, but it's much faster. And given these proposals, we just shrink the image to the size of the classifier, and we do classification as usual. This is really clunky to train, but it was really good at the time. And this is the basis of the state-of-the-art type of object detectors ever since. So doing all the, having all these proposals run through the neural network at the same time is really costly. So if there's a way we can cut down that cost, we save a lot of time. So we just take the image and shrink it down to the size of the convolutional neural network. And that gives us an output map. And then we can just refer to this output map instead of using the neural network all over it. And that saves a lot of work. A better option yet, since the region proposal network is still disjoint from the classifier, there's some context switching involved. And if we can bridge that gap, we can save even more time. So that's what happened a year later, where this network known as Faster RCNN does the region proposal based on the output map. And instead of generating the proposals using the segmentation method, we have these reference boxes called anchor boxes. So for each 3x3 grid on the output map, we suggest all these boxes and map them back to the original image. And we also regress on the size of the box. So we adjust the box based on bounding box regression. And that lets us train everything at once. And that's the state of art as of, I think it's still the best way to do it. So how do we do this with logotypes? Since we now have something to throw at the problem. Well, so logotypes are difficult for many reasons. It's not, if we don't really know the logo in the first place, it's hard to identify one. Usually it's where in the website or where it's very spatially dependent. And they can be arranged in different ways, and they can differ in various scales. They might differ in design, like for Pride Week, a lot of companies add rainbow colors to their logos. So it becomes a very hard problem in terms of where you draw the line for what a class constitutes. It's also something like there's only one true logo, and usually it's like a 2D image. It's not something that we find in a natural image. So it's usually just scaled. It's very rarely rotated. And yeah, so it becomes more a problem of identifying the sub parts of a logo. And of course, given the size of the internet, it's rare to find like actual like phishing examples. So we have two ideas of how to continue. Since we have very little data to work with, we will try to make a more general logo detector, something that detects things that could be logos, including icons and text in titles and in the header. And we are also looking into Siamese neural networks, which are capable of distinguishing between very different types of data with very little training data. Yes, so it turns out that a lot of the websites we can find online are just spam and something involving Google AdWords. So there's a lot of noise. So one of the first things that I looked at was cutting down this noise and making sure that we only find things that are either unique or something resembling actual websites. We have some cases where copyright law is not really respected, as in this case, where someone just straight up ripped off the Amazon logo. And we also have cases of actual phishing, where in this case, someone is trying to make their website look like PayPal. Overall, the experience of using the data factory has been really pleasant. The template that you provide is really helpful. And there are existing images with CUDA preloaded. And of course, help is really accessible too. I use PyTorch, which is really, really nice to use. It's very Pythonic. And it's really easy to get started like doing parallel work. You just wrap the model in NN data parallel, and that pretty much takes care of it. One thing that I had issues with is though, like you really need to make sure to use the data structures provided to you by PyTorch, as Python does not deal well with shared memory. So be wary. I also like using PyTorch Lightning, which takes a lot of the engineering away and just lets you focus on writing the code that you need. And for dealing with boxes and bounding boxes, I really recommend using Detectron. All these 3 tools make it really easy to get started with object detection. Yeah, and it's crazy how fast it is.